it is limited by how much time the students have, but certainly some of that responsibility can be carried by the students. So I think that's, I'm optimistic about that too in the long run. Student resistance is another clear barrier. I think that many students obviously have grown up in a system where what they were supposed to do is come to class, take notes, memorize what they were told, and then give it back on the exam, and they would get a good grade. And if you ask them to start learning on their own outside of class, you're going to get some pushback. And there are several ways that people have effectively dealt with this, I think. And the main one is to give them a stake in the process of reforming and explain to them on the first day of class what it is you're trying to do and why you're going to be teaching the way you're going to teach and what's in it for them. What are they going to get out of it? Or Gary Smith starts, I urge you all to read his little article, which is on the STEM Gateway website, about the first day of class and asking students what they really most want to get out of the course. And they don't say content, they say things like, I want to learn how to apply the knowledge that I get from the course to new situations, things that were on that list I showed earlier. And then he asked them well, which part of this, you've only got 37.5 hours during the term when we're going to be together in the classroom. So some of this has to happen outside of class. What is the easiest part for you to do outside of class? And I said, well, it's the factual knowledge. I can learn that on my own. And so you build student support for what you're trying to do. And you have to be sympathetic to the students. The students this is something new for many of the students. One example I like is from a physiology teacher at UT Austin in Texas who realized that, who has been teaching like this for several years, doesn't lecture at all. It's a studio class. The students do the learning of factual stuff outside of class. She realized that the process the students go through during this course is very similar to the stages that Kubler-Ross identified of death and dying, when you are told you have a terminal illness. You know, that you first, you did not have and then you panic, and then you get angry about it, and then you get depressed about it, and here's where you really need to give the students some support and explain again why you're doing it this way and what they're getting out of it. And then at the end, you get finally acceptance. So she actually has a clicker question that she puts up, and at the end she says they feel much more empowered. So she puts up this clicker question. She tells the students at the start, this is what's going to happen. You're going to go through these stages. Where are you this week? And that reference at the bottom of the slide is a lecture she gave about this, and it's a nice description of the process. So coming back to the list, this one's really huge too. And I think the answer to this, to the extent that there is one, and yeah, it's very related to the next one, is that faculty need help to do this. I mean, everybody, all of us have more than they can do, even me in retirement. And so it's a fair amount of work to transform a lecture-based course into an active learning-based course. And faculty need help to do this. They need release time, or they need people who can help them design things. And I'll come back to how we did this at Colorado in a couple of minutes. This is sort of related. Their award system. I mean, in most places, at least R1 universities, if you devote time to improving your course, you're not going to get much reward for it, probably. And I think this has to change, and administrators have to realize that the ball is in their court there, and they really have to change the way faculty performance is evaluated if they want to improve the teaching culture. But another related problem is even if a dean now wanted to do this, how would you know who's an effective teacher or not? The student course questionnaires are not particularly useful. I think most people agree. I think if we could develop a habit of measuring learning gains, you would have something concrete in your portfolio to show that yes, you are doing a very effective job in the classroom. And then this one is something that nobody talks about much, but I think it's critical. And there's a really interesting article that just was published recently about this, that if you came through a research-oriented graduate program, you were sort of accepted into a culture that considered research as important and laudable, and teaching as something a little bit less, or a lot less. And so it's hard to, in order to make this change, to focus some attention on teaching requires a change in professional identity, and that's going to be hard for most people to do, I think. So, but at least awareness that this is an elephant in the closet, I think, is really important, and this article points that out. Okay, so in the last few minutes, I'm going to tell you about the Science Education Initiative at CU Boulder, which was an attempt that was Carl Wyman's brainchild. He's a Nobel Prize-winning physicist that many of you have heard of probably, who basically, after he got the Nobel Prize, closed his lab and started working exclusively on education, physics education research, and then education in general. And so he convinced the president of the university to put up funds for a 5-year project, a little over $4 million, that would try to transform the way classes were taught in 5 different STEM departments. And he set up competitive applications from departments, and 8 or 9 departments applied to participate in this in order to get these funds. These are the 5 departments who did the first round. There's an additional one now that's going. All of these are strongly research-oriented departments that teach large numbers of undergraduate. And the basic idea is symbolized by this 3-point program, and this should look very familiar because it's what I was talking about before, that departments had to agree as a faculty, they had to take a faculty vote and submit a proposal to do this. And what they agreed to do was, first of all, define learning objectives. What should students learn? What do we really care about as part of the major? So reformulate the curriculum in terms of learning objectives, and then develop assessments to find out what students actually are learning. So all these things, and then look at what kinds of things can you do in the classroom differently in order to increase the performance on these assessments and reach these objectives. So introduce new teaching approaches, measure the effects on student learning. Just-in-time teaching is the old version of flipped classrooms where you let students do a lot of the work outside of class. And then use the assessment results to try to do better the next iteration of the course. So it's pretty successful, and one of the keys to success was that the money was basically used to hire science teaching fellows who were postdoctoral level people with PhDs in the discipline who had elected to pursue science education as a career rather than laboratory science or field science. When they came into the program, they got a crash course in pedagogy from Carl and other people associated with the program. And their job was not to teach, but to help faculty, get faculty involved in doing this and help them develop classroom activities, better assessments, things that take time and effort that the faculty didn't have time to do. And then also, these are people who had to publish during their postdocs, hoping to get jobs later. So they also spearheaded research to evaluate the kinds of things that were going on and whether they were working or not. And so as you might expect, some departments bought into this more than others of the group that got the awards. So geology had the most involvement with the program, and we were in there doing pretty well. This is another biology department in Boulder, and chemists not so well. But here are some of the outcomes and these data the program is now officially over. And so these are data from a couple of years ago, but a lot of faculty got involved, a lot of courses were impacted. A lot of people who had never published education research found their names on papers that investigated what was happening in their courses. Beyond the university, there's now Carl Wyman moved to Vancouver, to UBC, and started the same thing there, and that program is now 5 years on, and has done similar things. And all of the materials that were developed were made publicly available, so they're on a website that you can get at and use, anyone who wants to. And it really did change the culture, on average anyway, that faculty started talking more about teaching. They started doing less lecture and more active learning. They developed they used learning objectives as their instead of syllabi. About half of them used pre-post measures of learning, and many of them used attitude surveys as well. Evaluation of the program is still going on, but I think the answer to this question is yes, based on a substantial number of papers that were published by the STFs and their faculty colleagues on the results of classroom change according to this model. Carl's original idea was that if you did this for 5 years, you'd have a changed culture, set of materials that anybody could use, so you could bring in a new instructor and have them use the materials and fairly quickly get up to speed, and that when funding was over, this would be sustainable. And that was a little optimistic, I think. Without the postdocs there to help, some departments have done better than others in sustaining the changes that were made. But at least in our department, all of our core majors courses are using clickers now. They're all using learning objectives as their syllabi. So there really has been a change which I think is going to persist. The features that I think helped make it work are, one, that it was department-based. The departments had to compete in order to get these funds, and then they approached this one course at a time. So it's usually starting with the introductory course and then moving up toward interdivision courses. And I think the postdoc idea was brilliant. Postdocs were helpful and imaginative and energetic, but not threatening to faculty. They were educators coming in to tell them how to teach. They were people who wanted to help, and I think in general they were very effective. And it also developed an interdisciplinary DBER community, discipline-based education research, on the campus, which had never existed before. Physicists started talking to biologists and so forth. So it stimulated a lot of interdisciplinary interaction, and the STFs met weekly during the first part of the program to talk about education papers and learn more about pedagogy. So I think it worked fairly effectively, and it's something that was exported successfully to UBC in Vancouver, and Carl Wyman is now on the faculty at Stanford, as some of you may know, and I suspect he's going to try to do the same thing there. So it's exportable as well. So I'm going to stop and hopefully you have a few minutes for questions. I'd like to just acknowledge my colleague Jenny Knight, who was the coordinator for our part of the project in MCDD. Michelle, who was our first, and Jiao were our first STFs. And by the way, these STFs now all have good jobs. We were worried about what their professional careers might look like after this experience. They were all highly sought after. Carl and Kathy Perkins, who took over when Carl left. And so thank you, and I'll be happy to take some questions.
So I'm personally really motivated and concerned about creating a scientifically literate society of people who didn't major in STEM. Did your program or any research that you've read include non-major classes? And if so, how did the same system work in those classes?
Can everybody hear the question? Okay. Non-majors courses were not targeted specifically by the program. It was really designed to just look at the core majors courses, because one of the goals was to increase retention in STEM programs and graduation rates. But of course there was spin-off. I mean, a lot of the people involved in the project were also teaching non-majors courses, and so a lot of it spilled over into that. So I think it had a significant effect on those as well. Yes?
So you guys had kind of a really strong advocate
Yeah.
creating this, and,
Yeah.
and I don't see that emerging here from this department, maybe somewhere else, but I mean, it takes, you know, a big movement, and everybody's doing their own thing, and that becomes difficult.
Mm-hmm.
So has anybody done any science on the monetary outcome for the university or for the department of all of these students staying in STEM, so that you could sell it from a top-down perspective of this is really valuable and it's earning us money, and we can, you know, and that way you get some top-down push that this is the way it should go.
I haven't seen those data yet, but as I said, there's evaluation of this is still going on. And I haven't seen retention figures, but I know that's part of the study. So I would hope that you're right. I mean, we were very fortunate in several ways. One was we had this Nobel Prize winner who could go to the president and get $4 million, and or otherwise he would leave, which he did anyway. Then he got it announced first, and then they gave him money in Vancouver. So, but yeah, so I can't answer your question really, but I think we will be able to answer it. Yes. Yeah.
What questions do you put on your transcription pretest? I mean, you had some learning goals that involved transcription, right?
That's right.
And yet, when I looked through those, I think none of those could be tested on a pretest, because they were all these high-level things. And they also involved, I mean, so there's lots of things students can't even do until they learn some jargon, right? There's a certain level you have to have before you can begin to manipulate things in a higher level.
No, you're right. These were more examples of possible final exam questions than pre-test, post-test. So I don't have that right here.
I mean,
but
my purpose for asking is that I'm in physics and we do this force concepts and
well, that's where we got the idea.
And the problem, it seems to me, is that that's at a very low level. I mean, it was surprising when we realized that students could actually get a good grade in class and they still didn't understand some of the simple stuff. So it's good that we're going back and making sure they understand the simple stuff. But we want them to do so much more than just that. And I'm a little bit worried with the pre-test and post-test model that you kind of teach them to do very well at the really simple stuff. Because the complicated stuff you can't put on the pretest, so you can't.
That's right.
You can't get this, you know, numerical assessments, and you can go to your dean and say, "Give me a raise because I'm such a great teacher," right? So that's.
You know, I don't think the concept assessment idea doesn't do away with the need for a final exam.
Yeah.
That's really different. But it does. I mean, the physics is a great example. Well, I remember when Loon and Heston first developed that, and they. The story I've heard is they gave it to their students. They couldn't believe that students couldn't do this. Then they sent it to Eric Mazur at Harvard, who said, well, our students aren't gonna have any problem with
They
this.
can't
They
read.
couldn't do it. And they really didn't understand some of the simple physics concepts that belong. So you're right, it's a different kind of an assessment. But I think it can give you, and they're not, because we're designing these to be used in large classes, they're multiple choice, which is not so great. There has limitations. But you can design, I'd have to show you the test and see if you agree, but I would say that you can design questions that are fairly challenging, but don't contain a lot of jargon or things that a high school student shouldn't know, and get a pretty good idea of where they stand. Yes?
So, if you want to change a culture, you gotta start with young people.
Yep.
You gotta start with young faculty.
Mhm.
And, yeah, you mentioned that young faculty don't really get a lot of points for changing their teaching culture.
Yes.
I was curious about the Colorado Boulder example because yourself, well, a National Academy member, Wyman, who got the highest prize in science,
Mhm.
was able to go to the administration and convince them to give them money to do the science education program. But did they convince them that they should potentially reevaluate the way they evaluate the performance of young faculty and tenure promotion? Was there any inroads made there, or is it just a check?
No, I don't think there was. I mean, that's one of the more disappointing things about it. I don't think that the president bought into this. Said, first of all, I want to keep Carl Wyman on my campus, so I'm going to play with this.
Because, well, Carl Wyman's probably gone more than $4 million over his career. He's bullshit.
Right. But there wasn't a lot of support or even buy-in from at the dean's level or even the provost level at the university. So it's harder to change that. There was no incentive really for them to change, I guess. So that's a problem. And I would say, no, the reward system has not significantly changed. And as a result, most of or in our department at least, 3 or 4 faculty really bought into this and got excited about it and interested in it, and they were all tenured people. And a couple of junior people didn't want to deal with it because they felt it would take away from their chances of getting tenure. So that's a problem.
Let's have one more question, so again.
Wyman, what you said was you wanted to see cultures forming for intelligence in this education. But I see that with the PhDs trying to earn their living, they get off track maybe in the way they're communicating. There isn't that standard. There's these different directions that we can all kind of try and come back to one center in our department. But it would be a fault in the language not to keep the objective.
Not to keep.
Keep objective, objects, like if it's history, it would be document. If it would be biology, it would be cells, or physics, objects, keeping the object, and then building off what these objects have properties and are doing, like the teachers are doing, or the students are doing, maybe improper. It would be to say, students have this standard, and they're getting it from teaching, and on the outside they have a general text, which covers, basic format for a semester.
Yeah, I'm not sure I understand your question, but I think we are saying that you don't have to, the students can get a lot of things on their own if you ask them to or make them or challenge them to. And that content is going to take care of itself to some extent. I mean, I would go so far as to say that content is less important than some of these other things, because A, you're going to forget it. Have you ever seen the 5-Minute University that was on? Anyway, that's a little video. And that the content will be forgotten. If you can teach the students how to solve problems, how to learn on their own, they're going to be able to go out and learn anything they need to. And the content will, if you spend class time doing these active kinds of things, the content is going to take care of itself. Students are going to have to learn the content in order to participate in the process.
Thanks. Thanks. Let's say as you're walking out, this has been videoed now, that's going to be available on the website. No one's allowed to cut my phone, going off with an alarm, and put it on YouTube.